Class 12th Chemistry, Alcohols, Phenols and Ethers, and in this video we will discuss about physical properties of alcohols and phenols. Alcohols and phenols consist of two parts, an alkyl or aryl group, that is hydrophobic part, and a hydroxyl group. The properties of alcohols and phenols are mainly due to the hydroxyl group. The nature of alkyl and aryl groups simply modify these properties. First of all, we will discuss physical property boiling points. The boiling points of alcohols and phenols increase with increase in number of carbon atoms. As the number of carbon atoms increases, molecular mass and surface area both increases. This result in increase in van der Waals force. That's why boiling point is also increases. In alcohols, the boiling points decrease with increase of branching in carbon chain. As we know, as the branching increases, surface area decreases. That's why magnitude of van der Waals force is also decreases. That's why if we consider the isomeric alcohols, then the alcohol which has more branching has lower boiling point. Okay. The OH group in alcohols and phenols is involved in the intermolecular hydrogen bonding. I think you are familiar with this term, intermolecular hydrogen bonding. You can see in this diagram, this is oxygen is more electronegative. That's why this will acquire partial negative charge and this hydrogen will acquire the partial positive charge. This is the one molecule of alcohol. In the same way, this is the another molecule of alcohol. This oxygen is partial negative charge and this hydrogen is positive charge. Okay. Now this hydrogen of this molecule is bonded with the more electronegative part of another molecule via hydrogen bond. This is hydrogen bond. Okay. In the same case, this is phenol. Due to the presence of intermolecular hydrogen bonding, boiling points of alcohols and phenols are higher in comparison to other classes of compounds, namely hydrocarbons, ethers, haloalkanes and haloarenes of comparable molecular masses. For example, ethanol, methoxymethane and propane have comparable molecular masses, but their boiling points differ widely. You can see from these data, this is ethanol, molecular mass is 46U. This is methoxymethane, that is ether, molecular mass is 46. Actually, this alcohol and ether, these are the functional group isomers of each other. Okay, and this is propane, molecular mass is 44. All these three have comparable molecular mass. Now see their boiling point. Ethanol, this is 351 Kelvin, this is ether 248 Kelvin, and for propane this is 231 Kelvin. You can see the boiling point of ethanol is very high. Reason is due to the presence of hydrogen bonding. Solubility. Solubility of alcohols and phenols in water is due to their ability to form hydrogen bonds with water molecules. The solubility decreases with increase in size of alkyl or aryl groups. Simply we can say, as the number of carbon atoms increases, hydrophobic part is increases. That's why solubility decreases. Several of the lower molecular mass alcohols like methanol, ethanol, propanol, these are miscible with water in all proportion. Miscible means completely mixed into each other, whatever the ratio of water or alcohol is there. And reason is because these alcohols can form hydrogen bond with water molecule. You can see this is ethanol. This is CH3, CH2, this is OH. Okay. Now, this is partial negative charge, and in case of water molecule, oxygen is also partial negative and this hydrogen is partial positive charge. This is hydrogen bonding. The same way in case of alcohol, this hydrogen is partial positive charge and in water this oxygen is partial negative charge. This force is hydrogen bond. Okay, in the same case this is propane 1-ol. CH3, CH2, CH2, OH. It also forming these hydrogen bonds with the water molecule. That's why they are completely miscible with water in all proportions. Now see one example, 11.3. Arrange the following sets of compounds in order of their increasing boiling points. First one is pentane 1-ol, butane 1-ol, butane 2-ol, ethanol, propane 1-ol, methanol. We already discussed as the number of carbon atoms increases, boiling points increases. In case of isomeric alcohols, if branching is more, boiling point is less. Okay, now just find out. This is methanol, 1 carbon atom, ethanol, 2 carbon atom, propanol, 3 carbon atom. Now these butane 1-ol and butane 2-ol, 4 carbon atoms are there. We can say these are the isomers of each other. And this is pentanol, 5 carbon atoms are there. Now we have to arrange these alcohols in increasing boiling points. That's why we can say lowest boiling point is for methanol, then ethanol, then propane 1-ol. Now out of this butane 2-ol and butane 1-ol, butane 2-ol has branching. That's why its boiling point is less than butane 1-ol. This is butane 2-ol, then butane 1-ol, and highest for this pentane 1-ol. Okay. Now second one is pentane 1-ol, normal butane, pentanal, ethoxy, ethane. Now this is alcohol, this is hydrocarbon, this is aldehyde, and this is ether. Now this is normal butane, this is non-polar. That's why its boiling point is least. Then this is pentanal, aldehyde, and this is ethoxy, ethane. This is ether. Ether and aldehyde both are polar, but aldehydes are more polar. More polar means more boiling point. That's why we can say that pentanal has higher boiling point than ethoxy, ethane. Okay, this is ethoxyethane, then pentanal, and this is pentane 1-ol, alcohol. Due to the presence of hydrogen bonding, its boiling point is highest. Okay, thank you. Subscribe my channel to get the new videos from this chapter.